Good evening. I'm going to be talking about in this video the concept of factoring trinomials. And if you recall, we previously talked about the concept of factoring as being the opposite of multiplication. So let's go ahead and write that down. Factoring is the opposite of multiplying. And I want to specifically look at that idea with the idea of multiplying two binomial terms. So let's take two basic ones, for example. The binomial x plus 2 multiplied by the binomial x plus 3. And if you recall, when we multiply these two together, we use the process of what's often called FOIL. So when I multiply the first two terms, x times x, I get x squared. That's the f. When I multiply x times 3, I get 3x. That's the two outside terms, or O. When I multiply 2 times x, I get 2x. That's the two inner terms multiplied together, or the I in FOIL. And I multiply 2 times 3 and I get 6. That's the product of the last two terms, or L in FOIL. And so we said that factoring is the opposite of that process. So what we have is, if we're moving in this direction, left to right, we are multiplying. What we're going to be doing, though, is actually the exact opposite direction. We're going to be taking this binomial, or this product that we just multiplied out, which, by the way, it can be simplified, right? It can be simplified into x squared. 3x and 2x adds up to 5x plus 6. If we go from what we have here back to our product of two binomials, that process right there is what we call factoring. And that's what we're going to be taking a look at in this video, how to do. Now, in your previous algebra class, you should have learned how to do this. And there's actually a bunch of different methods that teachers teach their students how to do this. Some of you may before have created like a diamond with a box, or there's a number of different methods. Some of you may have used a kind of approach that involves factoring by grouping even. But the point is, there's a lot of different methods, and I can't teach you in our class every different method that every teacher taught you. It just isn't feasible. So what we're going to talk about is probably the way you first learn the idea of factoring, and that's just kind of a guess and check approach. So we're going to be taking a guess and check approach. Basically, we're going to be guessing what numbers it is that go into these different spots, whether it's the x times x or the 2 times 3. What numbers go in here that when we multiply them all out, we actually get what we had started with. And there's a couple things I want you to notice about the relationship between this trinomial that we're trying to factor and this binomial multiplied by this binomial, and that's that the first two terms should always multiply to give you this first part, the x squared, and the last two terms should always multiply to give you the last term in our trinomial. Then the two middle parts, the O and the L, if I add those together, this times this and this times this should add together to give me my middle term. So we're going to take a look at a couple of examples, but that's the basic approach that we're going to be taking a look at when we're going to try to solve this. So let's go ahead and start jumping into some examples. My first example is I would like to factor the trinomial x squared plus 6x plus 8. And we know that if it is factorable, when it is, it should have the form a binomial times a binomial. And I hope you guys are used to seeing this, because this is a pretty common form. Excuse me while I adjust my camera here. May have not been able to catch the beginning of that, but okay, so here we go. We have this binomial. We have x squared plus 6x plus 8. Now, I mentioned earlier in the video that this first spot and this first spot, when I multiply them together, they should come out to x squared. Where there's only one way we can get x squared, and that's if this is x and this is x. Hope everybody's all right with that. Now, then this spot and this spot, these last two spots, when I must multiply numbers that give me 8. Now there's only two ways you can get 8. We can get 8 with 1 times 8 or 2 times 4. Now keep in mind though that because of those two middle products, the O and the I part of your factoring or your FOIL process, I want to be able to add these two numbers up to get the number in front of my middle term. So I don't want 1 and 8, because if I add those I get 9. I want 2 and 4, because if I add those I'm going to end up getting 6x. Let's see how this works. So if I take a positive 2 here and a positive 4, I know that for my FOIL, x times x gives me x squared, and the last part, 2 times 4, gives me 8. Those parts should be easy. Now to check, what we're really looking for is we want to check these guys, and we want to check these guys. So if I check 2 times x, that adds up to, or that multiplies out to 2x. And if I check x times 4, that comes out to 4x. And sure enough, it turns out that 2x plus 4x is the 6x that we wanted. Alright, so this is the answer we were looking for. Our final answer is x plus 2 times x plus 4. Because when we actually multiply that out, it gives us the trinomial that we started with. Let's take a look at another one. Example B. If I take x squared plus 8x minus 20, again we know that this product should come out to a product of two binomials. Again, the first two are pretty easy. That should be x times x, because x times x gives me x squared. The last two, though, should multiply to give me 20. Now, how can I get 20? I can get 20 with 1 times 20, 5 times 4, 10 times 2. There's no way I can take a combination of 1 and 20 to add to give 8, or 5 and 4 to get 8. But 10 and 2, if I take a positive 10 and a negative 2, I'll end up getting 8x. So what I want here is I want a plus 10 and I want a minus 2. Because again, when I check this, multiplying these two inside terms gives me 10x. Multiplying the two outer terms gives me negative 2x. And when I add 10x and negative 2x, I get 8x. So this is the answer I was looking for. And that concludes the end of our first video. We're going to pick back up with some more examples here on the next video.